Siddhi. Siddhi is blockchain and self-serving IoT empowered privacy preserving cyber threat information sharing platform. These are the authors of this work. Iranga Bandar, I am the presenting author. Swooping Lea, Peter Poviti, Sachin Shetty, Kasundi Soisa. First of all, I will give a bit introduction about me. I am Iranga Bandara, working as a senior research scientist at VMAS, Virginia, USA. I am involved with various projects on blockchain, distributed systems, cybersecurity, machine learning, predicted learning kind of areas. Actually, our main motivation is doing research and apply this research into production grade applications. We always try to do research and build production grade application based on these researches. So Siddhi is one such production grade platform that we have built based on the research. This is my Twitter username. I'm available on Twitter. If you want, we can contact. Okay, now let's look at the background information. Cyber threat information or CTI. CTI sharing involves a process of collection, analysis, and sharing of cyber threat information among multiple organizations. CTI sharing may advertise the vulnerability that may be presented in the organization's infrastructure. That is, due to the reason it's highly sensitive. CTI is highly sensitive and has potential to harm an organization's reputation if it's leaked. For example, CTI may contain vulnerability in the organization. Attack happened to the organization, like information. If this information is leaked, so it is highly affect to the reputation of the organization. Due to this reason, so this information need to be captured in a privacy preserving and anonymous manner. Okay, so therefore the privacy and the anonymity of the participants in the CTI network are crucial. To manage this CTI information in the external cloud storage can cause problems such as data integrity and privacy. For example, if we use cloud storage to store this information, so the third party could access this information. So this information can be hacked or leaked. So for example, cloud service providers can directly access this information. There's a lot of concern on it. So that's the main thing. To address these concerns, with this research we propose Siddhi, a blockchain and self-sovereign IT-empowered, privacy-preserving CTI sharing platform to address these concerns in CTI sharing. So this platform supports traceability, anonymization, data provenance in a scalable fashion. Siddhi equipped with self-sovereign IT-enabled mobile wallet to ensure the anonymity of the reporters of the threat information. So basically, it captures all the threat information via self-sovereign IT-enabled mobile wallet. So in that case, all the information is fully anonymized and kept in privacy-preserving manner. See, the platform support TAXI and STIX standards for exchanging the threat information between participants in the blockchain network. If you look at TAXI and STIX, so the STIX is the most widely used CTI data expression language. The data communication protocol for exchanging the data expressed in STIX is TAXI. TAXI is the communication medium like this. So STIX the messaging protocol. Okay, then Siddhi architecture. We built this Siddhi platform as a layered system. There are 4 main layers in the system: distributed ledger, smart contract layer, stakeholder layer, and peer-to-peer communication layer. Let's look at functionalities of each and every layer. Distributed ledger, all the users cryptographic artifacts for identities, basically we call this as a DIDs in self-sovereign identity term. And cyber attack informations are stored on the distributed ledger. All the users cryptographic artifacts called DIDs and cyber attack information stored on the distributed ledger. Smart contract layer implement all the ledger functions such as identity handling, permission handling, attack information handling, and notification handling. Then stakeholder layer. So there are different entities in the system, mainly three entities: admins, incident reporters, and incident viewers. So these entities are in the stakeholder layer. DID communication layer. All the peer-to-peer data transfer or data exchange happens within incident reporters, viewers, and admins happened in the DID communication layer. All the peer-to-peer communications implemented on top of self-sorting and enabled with the mobile wallet. So all the mobile wallet communicate via peer-to-peer fashion in DID communication layer. Okay. Next, Siddhi functionality. So there are mainly three main functionalities on the Siddhi platform. First one is ID registration, then ID approval, and report view incidents. First, look at the functionality of the register ID registration. Uh, Basically, entities in the system, mainly incident reporters and viewers, need to register on the Siddhi platform before report or view CTI incidents. They can do the registration, ID registration via Siddhi mobile wallet application. So we provide the Siddhi mobile wallet as a self-sorting identity wallet. On registration, the user capture his personal ID information, image, organization information, like details. So the captured information, actual captured information, will be stored on the secure storage in the mobile wallet. The proof of this information will be uploaded to the blockchain as a self-starting identity proof. The main thing is we won't reveal any personal information to the outside parties. All the information will be stored on the mobile wallet in a secure way. Only proof of the identity, we call it as a DID proof, will be uploaded to the distributed ledger. Let's look at how this DID proof will be generated and uploaded to the ledger. So this is how it looks like. So basically, incident reporters and incident viewers capture the personal information, organization information. So then they store this information on the secure storage and mobile wallet, and application then generate a public private key pair. Private key will be stored on the secure key store on the mobile wallet. Then based on the public key, we generate the DID for this user. DID we give a specific format, so DID and base 58 hash of the public key. So this is the anonymous ID of the user. So then we upload this DID into the ledger. So this is the format of the DID. DID, name, role, public key, status, and this. You can see that it won't reveal any personal information, only the information of the public key related information. Okay, so that's how we capture the personal information and generate DID and create the DID proof on the ledger. So this is how mobile wallet looks like. Registering, we capture the personal information, we can capture the photo and other informations. Okay. Okay, the second thing is identity approval. So once this identity is registered, that identity need to be approved by the admin of the platform. Admin is the service provider who back this platform. Once DID proof is registered in the blockchain, it needs to be approved by the admin in the Siddhi platform. Admin can approve the identity information via the Siddhi admin web application. To approve the identity, admin require users' actual identity information which resides on the user's Siddhi mobile wallet. In this case, admin directly fetch this information from users Siddhi mobile wallet by using the peer-to-peer channel. So because personal information won't store any third party or any centralized storage, we store them on the user's mobile wallet. In this case, admin directly fetch this information via using user Siddhi mobile wallet and do the approval. Once the identity is approved, users can report or view incidents in the Siddhi platform. This is the identity approval works. So basically, first admin fetch the DID proof from the blockchain, view the DID proof, and directly fetch actual identity information from the user's mobile wallet. Basically, incident reporters and incident viewers. Then it can verify this information via offline process, maybe contact the DID owner via email or any phone call or anything, and do the verification and give a consent give a vote for this identity as a approved identity. Once identity app is approved, they can report and view the incidents. CTI sharing can be happen like that. Okay, now let's look at report and view incidents, how it's work. The registered users in the Siddhi platform report cyber attack information via the Siddhi mobile wallet application. We provide a mobile wallet to report the incidents. When reporting an incident, takes incident data, incident category, description, current status of the attack, action taken to resolve the attack, and efficient percentage of the action taken. So these are the main details we are capturing related to the cyber threat incident. The incident category defines the type of the incident, such as DOS attack, network attack, etc. These reported incidents can be viewed via the Siddhi mobile and web applications. So this is how the cyber threat reporting works. So basically, uh, incident reporters can report the cyber incident, then incident viewers can view. In here, one main thing is we have implemented some publisher subscriber mechanism. For example, incident viewers can subscribe for specific incident types. For example, incident viewers can, if they interest into DOS attacks, so they can subscribe for attack type for DOS attacks. In that case, when new DOS type attacks reported, it will be automatically published to the that corresponding incident viewer. So we have implemented it as a publisher subscriber way by using STIX and taxi servers. So that's the main idea behind the taxi server that we have used. Okay, this is how that mobile wallet application looks like. So basically it captures all the information, then it select the category. So this is the reported incidents. Okay, next finally the Siddhi implementation. We have implemented production version of the Siddhi platform. So this is the architecture of that production implementation. We build this platform as a microservices based architecture. Different services are there. So blockchain ledger to store the DIDs and the CTI information. So client interact with this platform via taxi server. So I will explain more information. So platform built with microservices architecture. Services are deployed using Docker Kubernetes environment. Microservice communication implemented with the Kafka using reactive streaming based philosophy. For the blockchain, we have used Rasa blockchain to implement the ledger functions. Rasa is another research that we have done. So we build a scalable blockchain system for enterprise application. Rasa is a scalable blockchain system for enterprise level applications such as big data, IoT, or cloud based applications. So we use Rasa blockchain to implement the ledger functions of the Siddhi. So smart contract implemented with the Rasa blockchain smart plus smart actor platform. So we invented a novel smart contract philosophy called actor based smart contracts. So we name it as Atlas. So all the ledger functions implement it as a smart contract functions implement as a Atlas smart actors. Firebase used to peer-to-peer communication, JWT based authentication service. Taxi server served as the entry point of the Siddhi platform. STI's messaging protocol is used by the clients to communicate with the taxi server. So this is the high level overview of the implementation. Okay, so that's the main thing I need to discuss. So if you have any questions, we can uh, talk them now. Okay, thank you very much for your time.